Good morning, everyone. My name is Jason Robinson, and I'm going to give you a little introduction to our Greece GeoStreamer program. We have some fast-track results, so we can generate some interest in preparation for the license round next year. So here's a brief overview of the talk. I'm going to give you an explanation of the location, a regional geological overview, with and then a description of some of the basins and plays that we're going to be talking about and looking for. And these can be split into three areas that I'll focus on with some examples of the seismic. The North Ionian, which consists of the Apulian Plateau, the pre-Apulian foreland, and the Hellenite thrust. Central Ionian, and then south of Crete. Here's an image of a map of the program itself. It extends from the Albanian-Italian border all the way around to the south of Greece to the easternmost extent of Crete. It's a regional program for general exploration purposes. In the north of the Northern Ionian Sea, we have a 10 by 10 kilometer grid of lines, and these extend out over the edge of the platform into the abyssal plain for some of these lines. To the south of Crete, we have a 20 by 40 kilometer grid, which is a more exploration, more sparse grid. And then there's an arrangement of lines in between to image the deeper waters. It's a sparser grid. And then some lines in around the existing discoveries, and we have a lot of legacy data in here for infill as well. It's in preparation for a license round in 2014. There was definitely a new data requirement. The legacy data is from the late 70s and early 80s. We acquired seismic and gravity and magnetics data. It's available on a multi-client basis, and it exists of 12,500 kilometers of new data. There were two acquisition parameters used. Everything required was recorded with a 10 kilometer streamer and using geosource. The lines in black were recorded with a 25 meter source interval to improve the inline sampling, and a 10-second record length. The lines in red were recorded with a 37.5 meter source interval and a 14-second record length to image deeper, image the basement, and if possible down to the crust, down through the crust of the moho. Here's the details of the acquisition parameters. So the source was either 25 or 37.5, and it was a geosource, so it was recorded, it was generated at 9 and 5 meter depths. So the data that's available now is indicated on the left here. It's the fast track, lines in red. So it's a subset of the data that we've accelerated through the processing in order to get an early view of what's there and get geologic input from interpreters so that we can have a geologically guided processing flow. On the right-hand side is a map of the existing data, legacy data, and the vintage of this is colored, and it runs from 1975 through 1985, and then some more recent 2000 data. It's all very short offset, short recording length, and most of it, as you can see, is imaged close to the coast in waters that could have been drilled at the time. It's a variable quality and variable source type as well. We're reprocessing about 6,000 kilometers of this initially, and that is to tie our new data into the coast and to tie it to wells, and for imaging in these shallow water areas where we weren't able to operate for environmental and practical reasons because of the streamer length. The fast-track processing flow is to remove the ghost with the GeoStreamer and GS processing, and then to run multiple removal, and then 1 kilometer velocity analysis for pre-stack Kirchhoff, and then apply Q compensation. So here's a little overview of the geologic setting. The Hellenide and Greek alpine activity has been pushing down to the southwest, and the speculated oceanic crust has been subducted underneath this as a result of this collision, this interaction. The current coastline represents the major uplifted inverted Hellenide activity. So it's a combination of the Ionian and the pre-Apulian, and then further to the east is the Gavro and Pindus. And the geologic domains that are represented in the offshore in this area are the Apulian platform, which extends up into the Adriatic and in Italy, and there are existing plays up here. On the margin of it, there's a shallow fallen basin, which is fairly narrow, down alongside Corfu, which runs along this red line here. And then on the other side of this is the sheltered area, narrow coastal area, which is the uplifted Hellenide and Ionian area, which is overthrust, thrust naps, and represents some potential. To the south of the Cephalonia fault, there's more of the pre-Apulian overthrust material, which extends out to this bathymetric contour, and similarly down to the south there's overthrust material. Out in the Mediterranean itself, on the outboard side of the Hellenic Trench and the trench systems to the south of Crete, is a larger slab of continental crust which overlies the oceanic, and there are areas where there may be very good potential for thick sediment, but it's in very deep water. So in the North Ionian, I'm going to go through the North Ionian central area around Cephalonia, or south of Cephalonia, and then south of Crete. So this is the North Ionian area. The play types here are represented by the Apulian platform itself, Apulian ridge here, and Northern, for example, has a couple of play models up here within the Apulian ridge itself. It's represented by Cretaceous to Eocene carbonates, and then overlain by more recent sediments, which could provide a good seal. Because of the tectonic regime, this is a flexed carbonate platform, and has a ridge that runs from south to north, and it dips down to the south towards the Cephalonia Wrench Fault. So there are plays in the actual Apulian ridge itself. On the margin of it is the fallen basin, which should have reworked carbonates down on the flank, and which is overlain by nicely stratified fleisch type sediments. And then close to the coast itself is the actual Hellenic thrust, which is represented by Paxi and Ionian sediments. So those will be different play type rather than stratigraphic and fault-controlled play types in the Apulian. These will be thrust, and if there's salt involved here, if it's present, could provide some plays up against the salt. So some examples. This line runs from the Preveza Bay area out across the Apulian platform onto the further out to the east. It drops down onto the Ionian. Here you can see on the northeast side the Paxi, or pre-Apulian, which has been upthrust and overthrust and has these fold naps. And the plays, this is an early version of the fast track processing, so it will improve from this once we get the velocities and imaging correct. But we're getting very good resolution in the near surface, and we can pick these tops of what we believe are the carbonates on this unconformity. Off the edge of that margin, there's a small fallen basin, and then you can see the flexed Apulian platform out towards the southwest. next line is a little further north. Here you can see the fallen basin, which we'll zoom in on a moment, and the carbonate platform with its these north-south running, because of the nature of the compression, it has these north-south running faults and horse graben. So there's an extensional regime in the center of the platform, which is relief for the compression over to the east. 2 days. EAG will be over by then. So we're going to zoom in on the shallow area here in this section. This runs from about 1.5 seconds here down to the base of this basin is this fallen basin, and the unconformity is at 2.5 seconds. So we have a good stack of sediment, and it's in about 1,500 meters of water. Here we can see the top of the unconformity of the carbonates on the platform. So this is Eocene carbonates, and the play model in here is that it will be reworked carbonates that would have come down onto the margin and then been overlaid and sealed to form a good seal. This basin extends further to the south. It deepens and provides some good opportunities. Here we have a line running from north to south along the Apulian, the Adriatic, the Apulian platform, and we can see some areas of also extension and sediments that have formed on top, and you can see it diving to deeper waters down towards the Kefalonia Range Fault, with a thinner layer of sediment down in the south. So the Apulian platform, flex carbonates, provides a good opportunity for structural traps up against the faulting. These stratigraphic traps at depth, if we have the porosity and permeabilities. If they exist, we need to drill it first. There's been speculation about the possibility that the Triassic evaporites extend this far to the west. If they do, there are opportunities below the salt. And then there are questions relating to the variable and temperature gradients, i.e. maturity, and we have analogues from the Italian side which support the opportunities for plate concepts at depth on the Apulian platform. The more recent scene is a very fallen basin, where we have these reworked carbonates and sediment that's been, the seal that's been provided by the Hellenized orogeny, and sediments of up to 2 kilometers thick in the south. And then there's the inverted nova thrust Paxi and Ionian zones, where we have structural traps and salt control, with potential for diapirism and inverted salt in upthrust. This model here is what plays into the central Ionian area. So here it's to the south of Kefalonia, it's in the Bay of Patras, Patriarchos Gulf, and runs down to the south to the Cataclon discovery. So in here it's been upthrust and overthrust, folded maps, very structural. This is a model that Triton put together in the Gulf of Patras. And our control here is really driven by the evaporites, with a combination of thin and thick-skin tectonics. The seismic, the legacy seismic, is really very poor quality, and so there are questions around whether the salt is diapiric or if it's thrust. And we have this we need to develop our understanding of the interface between the Apulian, the pre-Apulian, and the Ionian, and where those thrust boundaries are. What is clear is the top Eocene unconformity, so the top of the carbonates and the fleisch that's been deposited on top, and this is what's been drilled successfully in the past. So it's drilling on those highs. In most places we believe we have a good top seal, but because of the structural complexity, the reservoirs might be limited in extent. Further to the west there's a question of where the oceanic crust, what the extent of it is and how close to the coast it is, and what is the nature of this continental ocean boundary. So here's a line that runs from almost Catacolon, it's just at the edge of the image here, out to the southwest, and we can see the structural complexity and imaging challenge that this region will pose. But we're getting good imaging for these very early results, and we can pick our unconformities of the top of the carbonates from the thrust material, overthrust material. So the things that we need to identify are where the principal thrust sheets are, and the pre-Apulian or Paxi Ionian contact is, and then image these faults and identify the highs, and look for both stratigraphic and structural traps in the area, as well as identifying the salt, so we can see there are areas where it appears to be diachoric salt, Triassic salt that's been remigrated. Here's a north-south line in the same area. This line is 180 kilometers long, so it's highly compressed in the lateral sense. We're going to zoom in on this rectangle here in a moment, but we can see there's an extensional regime because it's perpendicular to the direction of principal stress, and very clearly delineated fault structures with smaller faults in between, nice unconformities, and extensional basins that have been formed with more recent sediment in them. Here we've zoomed in on this area, and we can see these nice reflectors with unconformities, nice what looks like top carbonate again, with erosional surface, which could well be karstified if they have an appropriate sediment on top. It could form a good seal. And then we have lots of structural control here as well, that if it's sealed could also provide good trapping mechanisms. And that really is the trapping mechanisms is the big question in Greece. There are hydrocarbon shows throughout the coast of gas and oil. Gas seeps down the coastline, so we know that there's a petroleum system that's working there. It's just a matter of finding the traps. We're going to zoom in on an area here just to show the resolution of the seismic in the near surface. So we're at 2 seconds just in here. And we can see the nice structural control, extensional regime of this faulting. You can see the nice unconformity and sediment on top, and thick layer of sediment beneath, which is known to be productive in terms of the source and the carbonates. So south of Crete, it's a more complex situation. Here we have a transtensional regime where we're on the margins of the Hellenide thrust. So this oblique convergent four-arc setting provides some challenges in terms of finding productive or prospective areas. Some of the questions that we posed for ourselves is there a Messinian salt in the area? We've seen different maps of the salt in extent, and it varies tremendously. Our geostream and GS data should be able to answer that question. What is the provenance of the sediment? For the thick layers of sediment that we've seen, where is the location of the Mediterranean ridge, and what is its structure if our lines extend that far? And of course then that Mediterranean ridge probably is the accretionary prism from the subduction. So here's a line misplaced. It's a little further down to the southwest. So it extends from the coast down to the Libyan border. So the northeast, and Crete is up here on the right-hand side, and it extends out through the overthrust Cretaceous to Oligocene, Eocene overthrust material with more recent sediments on top. There's the Pliny Trench, and then the stable abyssal plain, which we believe sits on continental crust with the oceanic crust beneath it, which is being subducted. And this over here is the accretionary prism material, which has been stacked up as a result of the oceanic crust subducting underneath. So here we know we have some good opportunities and thick layer of sediment. Over the continental crust with the sediment on top, we need to improve our imaging so we can figure out what this is and how much sediment we have here, but it's in extremely deep water at the moment. The next line runs from south of Crete to the southeast. So Crete is here up on the left-hand side of the northwest, and it runs to the southeast. So this is the same overthrust, inverted, uplifted material. It's the Ptolemy Trench, or Ptolemy and Strabo Trench, and these are a result of the uplifting and structural control at the near surface rather than a deep tectonic control. Outboard of this compressional regime, we can see extensional regime of Horst and Graben and material that's more recent sediments that's infilled in these Graben structures. And then further to the southeast is evidence of mud volcanoes, which we believe is related to the subduction in the accretionary prism and remobilization of sediments at depth. So once again here we have a thick layer of sediment, great opportunity for hydrocarbon accumulation and source accumulation. We have structural opportunities for this Horst and Graben regime. Once again it's in deep water, so it'll be challenging. And then similar structural control in the overthrust material up close to Crete. The real question is, what are the sediment thicknesses for these productive areas? So we'll see that once our imaging is improved. So the license round timing, acquisition of the seismic was completed early this year, and it's in processing now. It'll be completed. Data processing will be completed through pre-stack time migration by the end of this year or early next year, and then interpretation will be in Q1 of next year, and the data will be available as soon as it's ready. We have a plan to run some full tensor gravity gradiometry in the area as well, but that is subject to getting some pre-funding for the project. This will be really useful in helping to build our velocity model and to differentiate between salt and carbonates at depth in the overthrust areas. The license round opens in mid-2014 and will close late 2014. So our data will be available effectively from the end of this year, allowing 6 months to evaluate it and prepare for this license round activity. So our preparations for licensing is on track. We've got great data with some tremendous imaging potential and some challenges in the structurally complex areas. There's several plate types that we're identifying already. We know there's a working hydrocarbon system with the seeps and leaks at the surface. Maturity is known in some areas and it's quite likely in others. It's the trapping that's the challenge in the area. So it's once again a demonstration that the geostream and GS technology really does make a difference in opening up new markets and new areas and providing a superior ghost-free image. That's it. Thank you very much.